Hey, welcome to the SQV Structure Summit. And today we are going to talk about wind tunnel testing. And we have Dr. Abhay Gupta with us. So previously also we had a few interesting discussion related to wind engineering for low-rise structures, for high-rise structures. And we talked in a brief about wind tunnel testing. But today, in this entire session, we are going to address the interesting queries which we have received from the participants. Starting from the first fundamental question that what is wind tunnel testing, why it is required, what precautions may be taken while doing the wind tunnel testing, and etc. etc. Right. So let's invite Dr. Abhay Gupta and let's start our interesting session on wind tunnel testing. So over to you, Dr. Abhay Gupta.
Good morning from Noida.
Yeah,
It's a bright sunny morning on a winter
great.
downfall,
Yeah,
and really people are happy. At the same time, there is a change in the weather and transition is there. So things are all very pleasant. I'm thankful to Bhavin for having given me this opportunity
most welcome.
and very happy to interact with everyone. I have received several queries from you, and that shows that there is an awareness in the engineering community across the country, and even there are queries from outside also about this particular aspect of the building design, wind effects on buildings and structures, if I say in broad. We all know that I'll just give a brief of why wind tunnel testing is required. Basically, we all know that the flow of wind in the atmosphere affects any object, any obstruction which comes to its way, whether it is a structure, whether it is a block, whether it is human being, whether it is a tree, anything. If it obstructs the flow of the wind which is a fluid, a kind of fluid, so then it exerts a pressure. Pressure gets converted into force, and then the reactions are there. As a structural engineer, we are concerned with, or we are interested to determine the wind forces or wind induced response of the buildings or structures due to this flowing wind in the on the earth's surface. Uh, this particular thing is very difficult to convert into a mathematical formulation because of the random nature of the wind. Wind force is a random time varying load, and there is no fixed pattern about that. It may be from all the directions. It may have, you can say, turbulence. It may have eddies. It may have streamlined flow like this. So there's a lot of randomness in that. But engineers, with the help of mathematicians and statisticians, have been able to convert that randomness into some statistical parameters. Those statistical parameters are broadly like mean wind velocity, flow speed, then root mean square or the standard deviation means the measure of the fluctuations in the wind. Third is the energy contained in the wind flow. That is the uh, amplitude of the, you can say, wind speed converted into the energy which is embodied into that, which that will exert on the structure. And fourth is the size of the eddies which are carried in the flowing wind. In general, if an unobstructed flow is there, then there are no eddies. But the moment the wind interacts with any kind of the obstruction, then eddies are generated. So these four parameters in somehow statistical format have been included in some of the codes, Indian and international. We all know that IS 875 part 3 deals with the wind induced response of buildings and structure, the basic load characteristics, all those things. Though there are some other codes also in the India, particular specific to some structures, like for towers, there's a code, for chimneys, there's a code, for bridges, there are different provisions. But this is the basic code IS 875 part 3, which deals there. This code, if you look at, many of us have seen this code, there are some, you can say, tables, charts given. These tables and charts are giving you the value of CPE. CPE means coefficient of pressure external. This is external pressure, which acts on the surface. We are interested in that only. Basically, when the wind interacts with the structure, then the response depends on two things. One is the wind characteristics, the onset wind characteristics, which we call as, and the second is the structural characteristics. In particular, for the tall, slender structures, buildings, and other structures which are dynamically vulnerable, which also oscillate with the wind. There are two types of structures. We know that one are the rigid structures, which are small and which do not deflect or wave or sway when the wind force is exerted on them. And second ones are those which oscillate also. So when they oscillate, their interaction with the wind further becomes complicated. So there is a complete separate domain of dealing the wind pressure on rigid structures, which are low rise, they may be not undergoing sway or lateral deformations, much lateral deformations, which are not having high, you can say, time period, low frequency structures. But on the other hand, there are tall buildings and structures. So in both of these, interaction of wind with the structure is very important. Several experiments have been conducted worldwide, and some data has been compiled in the code, which we use. Now, this data, which is there in the code, any code, Indian, international, or literature, it is primarily for the standalone single structure. If I am talking about a low-rise building, industrial structure, then I am only thinking that that structure only is existing in the wind flow. I'm not considering what are the surroundings there, other structures. Similarly, when a tall building is there, I'm studying only a tall building. I'm only getting the values for a standalone structure. It seldom happens in the actual practice. There are always other structures around the existing or new proposed buildings or structures. Terrain category is one thing. Means when the wind comes on a structure, before that it has traveled 5, 10, 50, 100, 200 kilometers. So when it interacts with all those things on the way, please mind this particular statement, on the way, then it carries the effect of each and every object which it has overcome. Means its characteristics changes when it interacts. So all those characteristics when come to the building, we measure them with the wind speed, turbulence, intensity or energy spectra or eddy size. It is there. But the structures which are close by, near to the structure which you are studying or going to be constructed, they affect more on the structure. They are called as near field obstructions. Near field obstructions. So those near field obstructions, they affect very much, and we need to understand the modifications in the flow because of those near field structures. That makes the problem more complicated because the near field structure configuration changes. Your building may be on a elevation and there may be some other structures down the slope. There may be some tall buildings, tall structures. There may be some trees, a lot of trees around that. So every situation is different and it is really difficult or rather impossible to codify or develop a method for each and every situation. So the code helps you to understand or estimate the wind-induced response and wind forces for the standalone conditions. Some of the codes internationally have also attempted to put in some guidelines on the effect of other structures or buildings which are existing in the nearby area, that is called as interference effect. So there is a very limited codification about the interference effects. Means this particular thing, the actual situation wheresoever a building or a structure exists, has to be analyzed with something else. Now that something else, one of them is wind tunnel testing. It's a testing. I'll explain more on that later. Other option is to do the numerical modeling. Nowadays, computational fluid dynamics has advanced to a level where you can really define all the objects which are in the nearby. You can define other parameters. You can define the boundary condition and get an estimate of the wind flow pattern on the main structure to a reasonably good extent. Third one is artificial neural network and fuzzy logic. That is AI technique. So it is basically based on the past experiences, some algorithms are trained, and those trained algorithms help you to predict the response of the new structure. And as you get more and more data, you go on training that network or the algorithm, and then you get refined results. So these are some of the tools which are still far away from the actual scenario. So wind tunnel testing is a solution or is adopted worldwide for the complex situation. If I refer to IS 16700, the code in India for the safety in construction of tall building or basically for design of tall buildings, new code. It has made mandatory that all the buildings and structures more than 150-meter high shall be subjected to wind tunnel testing. However, IS 875 Part 3 very clearly says any situation or any building which is not covered by the provisions of this code, which is not a prismatic building. In general, we will go with a rectangular, square, circular, triangular, prismatic shape, which is not having change in the geometry as you go up or any offsets, or say in plan a building of plus shape, or because architects, they dream, they are very creative people. They dream some fantastic structures, and then next day they draw on the paper and show to the clients, and clients really get fascinated. And then it becomes a big challenge for the structural engineers like us. So they make the really very good shapes of the buildings. We all have seen Burj Khalifa. The shape of Burj Khalifa has specifically been driven from the viewpoint of wind resistance. It is there. But there are many other buildings. Recently, I was watching a video about that Capital Gate Tower, Abu Dhabi. अगर आप if you have not seen that tower, just go to Google Capital Gate Tower. There's a vertical straight core, but the entire building is leaning on one side. So thousands of tons of weight is on one side on the foundation, completely eccentric. Those kind of shapes are very challenging, and you can't get the answer even for a standalone that kind of shape from the code. So when IS 875 Part 3 very clearly says any building or structure which is not simple, which is covered in the code, whether it is low rise or high rise, it should be subjected to wind tunnel testing. Once we did a project in Dehradun, which was a ship type of shape, a cyber park in Dehradun. So again, that was to be. ONGC headquarters in Kolkata. It's a very different building, not very tall, just some 10, 15 floor kind of building. That's a very different kind of building. We see many such buildings in the country and abroad. So all those buildings cannot be assessed for wind-induced response using the code. You can only get a preliminary idea. That's okay. So we need wind tunnel testing for the complex structures. Now, what is wind tunnel testing? Similar to many other testing, whether it is material testing, whether it is soil testing. Now, the soil testing you cannot do sitting in the office. You have to take the equipment to the site, get the testing done. Every site is different. Similar to the wind tunnel testing. Now, in wind tunnel also, you need a simulated facility which will create a wind environment similar to the atmosphere. Similar means the characteristics of the wind flow on the building or structure should be matching in the wind tunnel and in the atmosphere. Matching means what? Those four parameters I told. Mean wind speed, turbulence intensity. These two things are covered by matching the profile. Profile of wind velocity variation from ground to top. I'll explain more on that a little bit later. Third is energy spectra. Fourth is turbulence scale, means size of the eddies. Some of the wind tunnels, they only work on the first two parameters. But more refined, better facilities, they have all four parameters matching simulation. So once you have simulated those four using different kind of things, then that is a wind matching. In that, you put a model of the building, scaled model of the building. You cannot put the whole building. So you put a scaled model of the building. So to some suitable scale, generally 1 is to 100, 1 is to 200, 1 is to 300, 400. To 1 is to 400 scale people have been using. If suppose the building is 400-meter high, means a 1-meter high model has to be made. So that model is made. Now the model is made of various materials. As I told you earlier, rigid or flexible. Tall buildings, by default, they are aeroelastic. Aeroelastic means they undergo lateral sway when the wind flow is there. But there are two ways to approach that. One is I keep the building model rigid, do not allow it to move, but I measure the surface pressure by instrumented techniques, or I make a model which also undergoes elastic reflections, which is a very challenging, complex thing. But these are adopted. So this facility, when I say wind tunnel facility, basically it's a device, it's a facility in which the airflow is generated by means of blower or suction fan. That wind flow is controlled in terms of quality. That wind flow is so modified by using some techniques that you are able to match the wind velocity profile in terms of wind speed as well as turbulence intensity. And then you are also able to match the energy spectra and turbulence scale. Once you have done so much of thing, then you put the model at a central place in the wind tunnel, which is called as test section. I have shared some literature with Bhavinji, and he will share with anyone who is interested or maybe in the group that you will find very good illustrations about some of the international wind tunnel facilities, and you will know about all these terms which I am speaking. So there's a test section on which the building or structure model is placed. That is an instrumented model, means there are sensors, there are transducers attached to that, which record, which capture the pressure generated because of the obstruction produced by this building in the wind flow. And then it is connected to a computer system, data acquisition system, computer system, where the entire data is stored and then post-processed. This is in simple terms, wind tunnel facility. So if I say, I'm very happy and we are proud that in India, we have some of the very good world-class facilities of wind tunnel. The first one was established in IIT Roorkee in 1985. I have the privilege of working there. I did my doctorate from there only. And then the next very good facility is at SERC, Chennai Structural Engineering Research Center. Third wonderful facility, which is not only for the buildings but also for the aerospace applications, is IIT Kanpur, which is also called as National Wind Tunnel Facility. And there is one more which has been recently established at Guna in Madhya Pradesh by JP, Jayaprakash Group. It is Wind Engineering Application Center. It is one of the finest wind engineering center in the country and in this region of the world. But there are some more facilities like RWDI is a company from Canada, Singapore. RWDI has established one very good facility in Thiruvananthapuram or Trivandrum. For building, these many facilities are there. But there are some more small facilities for in academic institutions. Some IITs also have. Some more are coming. I have heard that Graphic Era University, Dehradun is also coming up with a wind tunnel facility. So these are academic institutions where they may not go with the professional testing, but we have some very good facilities. Beyond that, Hindustan Aeronautics Limited and National Aeronautic Lab in Bangalore, they have very good wind tunnel facilities, but they are for aerospace application. They test supersonic planes, aeroplanes, and Agni missile and all those kind of things. So they are different kind of thing. When I talk about the wind tunnel, I must explain you one more term. Then after all, what is the difference between the tunnel for building and tunnel for the aerospace? Yes. Fundamentally, buildings are all on earth. So the nature of the flow has to be the one which is close to the earth surface. While aerospace vehicles, they are in the air, several kilometers above the earth surface. When they are several kilometers above the earth surface, means there is no obstruction to the wind flow there because of all these things which are existing. So there is a primary difference between the free flow, which is there for the aerospace, and the obstructed flow at the earth surface. This obstructed flow at the earth surface has variation from zero speed at the ground contact to free stream flow or maximum, let's say 300, 400, 500 meter, where the effect of obstruction more or less is zero. After a certain height from earth surface, say 300, 400, 500 meter, the flow becomes a free flow. So the height from zero on ground to the free flow is termed as atmospheric boundary layer, ABL flow. And all our buildings and structure, they are immersed or they exist in atmospheric boundary layer. So we are more concerned and we'll be discussing about the atmospheric boundary layer flow. So all these wind tunnel which I have spoken for the building facility, they have the facility to develop atmospheric boundary layer. But like IIT Kanpur facility, they also do a lot of aerospace testing. So when they do that, they do little modifications and they produce a free stream flow. Any of you, if you get an opportunity to visit any of these facilities, you will learn more about that. So with this brief introduction and the necessity, we can take up the queries which have been raised. I have gone through the queries, very interesting. And maybe some of them have already been answered in this briefing, and the more complex ones or the specific ones we will take now. So, Bhavan, please, let's go to that.
Yeah, yeah. Thank you for the quick introduction for the wind tunnel testing. So now let's have a quick discussion about the queries whatever we have received. So what we are planning, as you can see that this is the session which is being recorded offline. But what we are planning that after publishing this session, if participants have more queries, then we may conduct a live session for addressing those queries. So let's
Correct.
start with the queries which we have received. Just let me share the screen. Yeah, so let us take up one by one point. Like one
How
of the
mathematical model is developed for wind tunnel test? I could not understand the question, but I believe that he is asking about the simulation, that
Mm,
how the different parameters are simulated. So
yeah.
it is a scaling for like if I am doing a building of 400-meter high and I'm modeling that to 1 meter, so my length scale or geometric scale becomes 1:400.
Mm,
The same scale I apply to everything else in terms of length. But then velocity scale, suppose my design wind speed at the place is say 50 meters per second, and
mm,
I cannot develop a 50 meter per second inside the wind tunnel.
yes.
Normally, wind tunnels develop um, and test 10 to 20 meter per second. Suppose a facility is there which tests at 10 meter per second. So 10 meter here and 50 there. So my velocity scale becomes 1:5. When I have the geometric scale, I have the velocity scale, I can get the time scale. Okay. So this way, various scales are deduced, and then a formulation of the you can say prototype prediction is done. In some of the literature which I have shared, it is explained there. So this is the way the mathematical model for wind tunnel testing is developed.
Okay. Next question is how do
From Satyajit, how do you simulate the surrounding of a tall building under consideration exactly in the wind tunnel facility? Yes, this is something very challenging. But whenever a project is to be tested in the wind tunnel,
mm,
generally the wind tunnel testing agency will ask the client that
mm,
if you can provide height and size of the building in about 10 times the, you can say, height of the building kind of thing, about 10 times, which affects. But it is very difficult to get that data. So in the very nearby, say about 3 to 4 times area, they ask the client to provide some details of the building. Else, nowadays, Google Earth provides very good information about the objects present. And then there are good tools and techniques which convert that Google Earth data into the 3D images, which then are converted into physical models to be placed around the building. Some of the photographs which I have shared in those literature, you will be able to see those building blocks which have been placed. Um, Most of them nowadays are being done through the Google Earth. Curious to know about the wind tunnel testing. I've already explained in detail. Now the next stage is you should visit a wind tunnel testing facility whenever there is a test going on.
Right.
Let me know if you are interested. We can certainly organize to one of those facilities which I have spoken.
Yeah, that's
Pallavi
good.
wants to learn about wind tunnel effect.
Mm.
Uh, Pallavi, this is not wind tunnel effect. It is wind tunnel is a facility which studies the wind generated effect, wind induced response of the buildings and structure. So wind induced response means a building or a structure will undergo a force, means pressure, then force, then that force will get transferred to the structural members and to the foundation. So all these things, and then lateral deformations. How much is the lateral deformation in wind tunnel? And then it is computed, backward computing using some mathematics, that how much would be the actual prototype deflection, deformation, and what would be the acceleration in case of tall structure. That's very, very important. We also calculate the acceleration with the code, but instrumented models can also provide you the acceleration value. So these are some of the wind induced effects which are obtained from the wind tunnel testing. There are many more things for buildings. How do the flow is get modified? There is one more big area as far as tall buildings are concerned, pedestrian level wind. Whenever there is a tall building constructed or a group of tall building is constructed, then the wind flow pattern near the base gets significantly modified. It becomes violent. If you have experience, if you stand on the ground between a cluster of building and if there is a wind flow, then you really get very, you can say, turbulent wind. And it has been observed that children and senior people, old age people, they are means they are more affected with that. So this is a very means a gray area which is always studied in case of tall building study, and then architects are requested to make some downwash cutters. This is called as downwash. So downwash cutters are introduced so that the wind flow pattern at the pedestrian level is not much disturbed. Beyond that, atmospheric pollutant dispersion is another area. Suppose the industry is going to be set up, then how that pollutant dispersion will take place. There's an environmental wind tunnel testing not being discussed today. So these are some of the effects of wind flow on the buildings. Nitil says, I'll attend the session and I'm doubt, want to learn about the wind tunnel. Same as I've explained. Provide its basic and guidelines, soft copy PDF. Basics I have explained. Guidelines, soft copy means you want to make a wind tunnel or you want to test a wind tunnel. There are some international documents about the wind tunnel testing. I'll share that also. Otherwise, in India, now BIS has taken up preparation of a wind tunnel code, guidelines for wind tunnel testing. That document is under preparation.
Okay.
How is tune mass damper selected? How is it incorporated in wind tunnel testing? For tall buildings with swimming pools, would their location change based on resonance or it's mostly? I will skip this question for now.
Yeah,
I'm not
sure.
going to into the damping side. That's an advanced topic. Okay. So just इसको highlight कर लीजिए for further next discussion.
Sure.
Ajay Jadhav is writing scope of work. I already explained the scope of work, but if you need any more, you can just write specifically.
I think he's
Ankar,
asking,
I don't know how to. Yeah,
I think
please.
he's asking that how the scope of work may be detailed out while preparing the terms
Well,
of. Yeah.
okay. Generally, uh, the developer, engineer, or a structural consultant would specify that what parameters are you are interested in. Means you provide the building configuration, and then you will say, we need surface pressure, we need base forces for the foundation design, we need surface pressure for glazing in facade, we need pedestrian level wind study, so we need standalone, we need interference effect study. These kind of parameters are specified, and accordingly the wind tunnel testing agency will quote for that proposal, even including the future development. In one of the projects, we also, because the life was more than 50 years, 100 years plus, so in that, we also asked the wind tunnel testing to be done for a development of structures in 100 years period from now. Some anticipation. Nobody knows what is going to happen, but some anticipation, and particularly from the predominant wind direction of that area. So that is a part of the scope. I don't know how to apply wind tunnel in ETAPS model. Okay, this is really a good question. Basically, when you go to an ETAPS model, then you need to apply the wind force. First, you do with the code, whatever there is a figure 4 given in the code, IS 875 part 3, which gives you CF value. And then you, from the CF, you work out the force, wind force at every story level. And generally, people are applying that on the center of mass or at the center of diaphragm in the ETAPS model. Actually, that's not a correct way. But since it is easy for everybody, so people have started doing that. See, there is a marked difference in the earthquake and the wind force. Earthquake force gets generated on the center of mass. It is at every mass, and therefore applying a net earthquake force at every diaphragm at the center of mass is reasonably good. However, wind force do not generate at the center of mass inside the building. Wind force generate on the surface because the surface is obstructing. So it should be applied on the surface. If you cannot apply on the entire facade as uniformly distributed load in terms of the Newton per mm square or kilonewton per meter square, then you can divide that into story levels. This is also written in the code that you can apply on the story level above and below as a horizontal line force, because at every story level you will have a beam, horizontal beam, which is connected to the main lateral load resisting system. So you can divide that entire wind force by the length of the building, by the width of the building perpendicular to the wind direction, and apply it there. That's a more reasonable way of doing. Some people believe that applying entire force on the windward face is not okay. But if you read IS 875 part 3, they have very clearly said that this force has to be applied on the windward side, complete wind force. It is there. आप देखिएगा. So in ETAPS, when you go, you should apply horizontal wind force as a line load at every story level. That is in the ETAPS model. Same thing when you give to the wind tunnel testing agency, you should ask them to provide story level force, complete story level. They give a story level force. They give a single value. You can ask them to provide you a complete horizontal line load. They can easily give it. So this is how it has to be done. That's the correct way. Uh, I'm I'm discussing on some projects with some proof consultants these days, and I'm facing this issue. So I'm
Yeah.
trying to drive my point of view, and I have discussed with many other experts also.
Yeah.
Harish Patel wants to understand the output data of the wind tunnel testing. Primarily, output data of wind tunnel testing, you get, there are two types of testing done for the tall building: high frequency pressure integration and high frequency base balance. In these two, in case of high frequency base balance, you get 6 force components at the base: Fx, Fy, Fz, Mxy, Mxz, Mx, My, Mz, team. So these 6 component you get. Uh, Dynamic forces, their complete variation, mean, dynamic, and everything. They are mathematically then to be distributed, which wind tunnel people do and give you. They distribute mathematically over the entire height and give you the story level forces. This is one way. Second one is high frequency pressure integration, in which over entire surface, small pressure transducers are there, sensors are there, which collect the pressure data, and then that entire pressure data of the distributed sensors is integrated to get base forces as well as the story level forces. So this is for tall building. When it comes to the slow rise structures, then entire low rise structures, again, you can either mount on a base balance or you can have the entire surface, including the roof and wall, everything through the pressure tubings or pressure transducers. And then you can get the pressure values and pressure contours over the entire surface. So this is what you get from the output. You can also get lateral sway, acceleration, all those things are there. How to take the wind calculation pressure in tall building design? I have explained already. You should use figure 4, CF approach, not CPE, CPI approach. It is not correct. In a tall building, when there are internal walls are there, CPI is never developed. Internal pressure is never developed because there is no through passage to the wind. Correct? So it should be CF approach. Atul says, curious about scaling of load and results. Scaling of load and forces, I have explained that based on the geometric scale, based on the velocity scale, based on the time scale, based on the simulation of the mass of the building, you deduce the prototype conversion scales, which are done by the internal testing agencies, and they give you the actual prototype value. They ask you to provide dynamic characteristics of the structure, the mass distribution, the mass moment of inertia, the time period of the building, all these things they use, and they provide you the complete story-wise forces on the prototype. Samir Shah, CFD versus wind tunnel. Wind tunnel is authentic, not only authentic, but more reliable, more accurate description of the phenomena. CFD still is developing and still it is based on some of the inputs that you provide. So CFD is giving you a fairly good idea, but ultimately, if suppose there are some 10 cases to be studied, you can't subject all 10 cases to the wind tunnel testing. Maybe you can do a preliminary study in the CFD and select some one or two specific cases and then subject them to rigorous wind tunnel testing. That is the way combination it should be. Just understand the design criteria. This is not related to the wind tunnel testing, but if you have anything specific to wind tunnel testing, please ask separately. Suresh Nagar, difference between static and dynamic wind analysis through wind tunnel testing. See, wind tunnel testing has nothing to do with the static or dynamic. If it is a rigid structure, like a low-rise structure, the output will be in terms of static pressure. That will be both CPE, CPI you can get. But when it is a tall building, which is dynamically vulnerable, then modeling will be done according to that. And building dynamic characteristics will be fed into the analysis, which is done after getting the force on high frequency force balance or high frequency pressure integration. And then the prototype results are obtained. So this is the difference in the static and dynamic. I also cover the topic in detail of wind analysis in ETS. I have already covered that. You want to apply wind loads as a pressure on the outer cladding, how to obtain those pressure from wind tunnel. Exactly what you are writing is the way it should be done, and I have explained it. I'm very happy that you are discussing this. Saurabh Sanjay Gandhi. Coming down to 32, in tall buildings, wind calculation is as like normal calculation or any special coefficient you have to consider. No, it is as prescribed in the code using the CF approach. Same thing. Tall buildings. And there are, for dynamic, you have to go to the dynamic section, gust factor approach. Now, the only thing is, analytically, a long wind response, the procedure is very, very clear. Analytically, a crosswind response procedure, which is given in the code, not only Indian, worldwide, you cannot have a mathematical formulation for a crosswind response unless and until there is an input from the wind tunnel testing. So, if you look at our code also, there are two graphs given. One graph is for one type, one plant shape of the building, other is for the other plant shape of the building. Now, they are specific to those plant shapes and those terrain categories. If there is a change in the plant shape, aspect ratio, then those graphs are not valid. Why? The CFS value, crosswind force spectrum, it is made obtained from the wind tunnel testing. The moment aspect ratio changes, the moment plan aspect ratio changes, the moment building shape changes, the CFS changes. Because in crosswind response, resonance is very, very important and critical. The vortex shedding frequency on either side will be creating the forces, but when it reaches to a certain resonant frequency with the building, then it is a violent vibration. And that particular thing varies from building shape to shape, different terrain category, wind flow characteristics. So using that in the code, it is given because only this much was available. But probably I believe in next few years, another version of code should include more data on the crosswind force spectrum. More graph should be there. Okay. So I hope Venu, you got your answer. Related to aerodynamic effect on high-rise structure. Yeah. Aerodynamic structure means any structure which is dynamically vulnerable, who's who qualifies to be analyzed for the dynamic effects. Their aerodynamic effect should be studied. Modeling is done on high frequency base balance or HFPI, but then the analysis of result is done using the dynamic characteristics of the building. But if suppose there is some specific element, some specific slender attachment which further needs the study for the aerodynamic forces, then it has to be done in the wind tunnel testing by applying more sensors. There is no procedure as per the code to study that thing. When is Ravindra Golia is asking, when is wind tunnel test of a building or any structure necessary? Ravindra, I have explained this. Ravindra Golia is from JUET Guna. So he will be one person who will take us to the that facility. So I have already explained when it is necessary. Which building shape is good for resisting high wind pressure for tall buildings? Which type shape of building you found is very effective in resisting high wind pressure at top level of building during wind tunnel testing? See, any shape which does not promote a vortex shedding, like streamline shape in the plan, but streamline shape for building is not possible. So corner modifications are done. Chamfering, some gaps, openings are there. They really help wind-induced response to be controlled significantly. As far as along wind response is concerned, whatever is the building area that has to be considered, that is, there is not, but when it is gust factor approach, then probably the more stiff buildings will undergo less. But every time it is not possible because of the other considerations, earthquake design and other thing, or maybe architectural restrictions that you create a very rigid structure. So whatever structure is there, you can just consider some modifications in the corners or that. But in India, we rarely get this opportunity because architects freeze everything first and then come to the structural designer. That is the thing. Wind-induced acceleration. Yes, there's a big issue of wind-induced acceleration, particularly in the tall buildings and also in the for the people sitting in the balcony or the objects kept there. And there are limits prescribed in the code. Code also gives an expression to calculate, but with wind tunnel also we can work out wind-induced accelerations are there. It should be controlled properly. Hiren Desai ji is asking application of results to structural model. I already explained that. Dr. Dhawan about wind analysis. Sir, I hope I have been able to address this. Hemang, how does the impact of wind on steel buildings compared to concrete? What is the threshold building height base dimension to decide the material of construction? There is as such no prescribed thing. You can make anything in concrete, you can make anything in steel. Nowadays, very good concrete systems, very good composite systems are there. As far as how does the impact of wind on steel building compared to concrete? Steel buildings have less damping, so they undergo larger accelerations. Concrete buildings are more rigid, so certainly concrete buildings are comparatively less affected than steel, but then steel resistance is far better. But the only thing is connections have to be very carefully done, because wind in a crosswind direction is, and it's a regular phenomena. See, unlike earthquake comes once in several years. But in wind, you are designing elastic approach. In earthquake, you are going to the non-linear. In earthquake, you are expecting building to damage. In wind, you are not expecting building to damage. They remain elastic. So they keep on oscillating even under the ambient vibrations, even under the normal conditions. So for that, those connections of steel should be very properly designed and detailed. That is important. In concrete, it is all rigid. So certainly, but a very high concrete building you cannot make. It has to be either a steel concrete composite or a pure steel building. Correct. So depending on that, you have to decide. It is not only the wind which will decide. There are many other parameters. Explain the important key points of wind tunnel testing. I have explained to a large extent. You should be very clear about the scope and objective. You must look at the facilities of the wind tunnel testing in terms of the sensors, what quality of sensors they are using, what characteristics, what quality of profile they are able to simulate, and also what quality of data acquisition processing they have. That is very, very important. These are the key points of a wind tunnel testing facility. Anil Shah is asking effect of adjacent tall buildings and also effect of any future development which may come but not known. Anil bhai, yes, very true. Effect of adjacent tall buildings must be considered. Must be. Normally, there are group housing projects and wind flow gets significantly modified. So, this should be any building which is more than half the height of the principal building within about say 10B. B is the dimension of the building perpendicular to the wind. Within 10B affects the the building. So you must be very careful that if there are any tall buildings taller than half the height and within close vicinity, they affect the wind flow pattern. That should be part of the study. That is why some guidelines have been provided in the IS 875 Part 3 about the interference factors in zones. That is the outcome of my PhD thesis, which I did at IIT Roorkee in 1996, and some other researchers also. Any future development which may come, see, as long as 50 years of life, 60 years of life is concerned, you can expect a normal development. But if suppose there are some high-rise buildings coming up closer, then immediately the owner of the existing building should write a letter and should give a notice to the developer of the new project that a proper wind tunnel testing should be done. And if there is any adverse effect, it should be properly taken care of. There have been cases in the world history where legal suits have been filed by the existing building owners on the proposed new development owners for this particular reason. That is the thing. Dr. Arun is asking, para 4.16 pressure coefficient equal to 1 minus this, where Vp is equal to wind speed at any point on the structure at a height corresponding to that of Vz. I could not understand the question, Dr. Arun.
Question is not clear. Yeah.
Para 4.16 pressure coefficient equal to which code? Para 4.16. Maybe I'll have to take up separately with him.
Yeah, we'll just highlight this point.
Yeah, I think Dr. Arun is from BIS.
Yeah.
Raghuvi, to understand the difference between the results after using codal provisions and experiment. Yes, there are gaps, and the code says if your wind tunnel testing results are lower than the analytical results, you should not use lesser than 70%. In most of the cases, you get a benefit of the wind tunnel testing. There are many parameters which are taken conservatively in the codes, and hence wind tunnel testing affect. In many of my projects, I have seen that we are going to that 70% value. Suppose I am getting 100 kilonewton force from the analysis, I am getting 70 kilonewton from the wind tunnel testing, and it significantly makes a change in the design. Parth, want to learn in detail about wind tunnel testing? Okay, Parth, I have explained in detail. And more if you want, Maybe, Bhavin, we can have a separate course on that training program.
Sure, definitely.
Relate wind tunnel results with E-tips. I have already done that. How to go through the wind tunnel test results. Explained already. Shailesh, crosswind and alongwind application simultaneously assignment to. Yes, there are provisions. You have to apply both of them simultaneously. There are load combinations given for both of these simultaneously to be applied. I have no idea about wind tunnel engineering. I want to know about it from fundamentals. Sir. I've explained in the beginning about the fundamental. Please go through it once and then go through the IS 875, and then there's a handbook on IS 875 part 3, which was prepared by a team under Professor Prem Krishna. I was also a part of that. It is available on NICEE website. You can read that for knowing more on that. There are worldwide documents on the wind tunnel testing. I have shared some of them. There is a document from AG Davenport Wind Tunnel, Ontario, Canada. It's a very good document. Ramiz Rada about the wind tunnel test and how to apply in ETIPS. Already covered. How can we interpret data from a wind tunnel study? Is it possible to simulate wind tunnel test using software like NCS? Yes, I have explained that CFD you can use. It is being done on a large scale. What should we do when wind tunnel results are low when compared to ISCO? 70%. Straight away. Not less than 70%. Ravi, wind turbulence. Yeah, wind turbulence means basically the correct change in the characteristics of the wind because of the obstructions present at the Earth's surface. Whenever the wind crosses any obstruction, then eddies are generated. Those eddies are generated in vertical plane as well as in the horizontal plane, depending on the shape of the object to which it is obstructing. When these get mixed up with the flow, then there is a fluctuation in the wind speed. That fluctuation is called as turbulence, and it is measured by root mean square value of the statistical parameter. If you draw a plot of time varying wind, it is a zigzag value, and then some statistics is applied to get the mean velocity, peak velocity, RMS velocity, and they give the measure of the wind induced turbulence. But you can also measure the size of the eddies. That is important. In IS 875 part 3 gust factor approach, there is a parameter called L. So that indicates the wind, this eddy size. Calculation of terrain coefficient for different terrain categories. Don't bother about these things. They have been assigned. There are 4 categories. Now we are making them to 6 categories. Just try to match your condition with one of those to which it is closer and use that value prescribed. It has been measured worldwide at many sites, and then those coefficients have been obtained. So you need not do the coefficient calculation. For seismic force, we use dampers to dissolve for. Is there any similar one? Yes, there are dampers for wind also. Similar. Same thing. Brief insight into wind tunnel testing and aerodynamic parameters which are generally used in wind tunnel testing. I've explained about them in detail earlier. I want to attend the session for gaining knowledge, sir. We have to go to wind tunnel testing for steel plus 15 floor? Code says no, but code again says if the steel plus 15 floor building exists in a group and it is complicated plan, if you cannot calculate, see 15 plus steel would be something around 60-65 meter maximum height. You can use the codal approach and you can get a conservative value, not an issue. Depends how slender it is. You have only said height. What is the base width? If it is too thin, yes, you should do. How wind tunneling plays a major role. It plays a major role because that is the authentic, correct, reasonable way of studying the wind-induced response and wind forces on the building structure. You can't get it otherwise only from the code. Relation between wind tunnel test and code equations. No relation as such. Wind tunnel testing is an actual observation of the data of the phenomena on the simulated model and wind characteristics. Whatever results you get, you can compare them with the code equations. That's all. Except the crosswind response value. In that crosswind force spectra has been obtained from the wind tunnel test. Wind force received from the wind tunnel test, how to apply in ETF's model and whether combination will same. Yes, it is same combination. I've explained it. And drive, get R in orthogonal, apply or incline. Orthogonal only. How to back check whether the force received is correct. See, any data obtained from an experiment can be checked for the correctness only with the checking of correctness of the parameters and repetition of the result, which wind tunnel people do. They do not give you the result just by one time testing. They will test same thing 3 times. So whatever you obtained is one obtained for that condition. Correct. And as per IS code, calculation of across wind is confusion. The graph is also not completely no typical calculation. Typical calculations are there. You refer to the handbook. They are there. But you are true that confusion in the sense that only two graphs are there. If there is a different building, you have to use one of these. No peak acceleration of flow to check in which case 20 year or 50 year as per IS. No, there's an acceleration formula given for tip acceleration. You can convert that tip acceleration. Basically, it is a tip acceleration only. The entire building will have the same acceleration. It is no separate acceleration. But if suppose there is something mounted on a particular floor, the acceleration of that, for that you have to do a separate calculation, like in machine foundations.
Yeah. So what I think
Uh,
what is asking that whether we should check it for 20 years of period or 50 years of period.
20 years, it is given in the code.
So,
20 years acceleration.
yeah.
I had Manjunath is asking, I had doubts regarding when and how to take wind. I have explained in detail, sir. If you have more queries, please call me. Common challenges faced during wind tunnel testing and how they were resolved. Oh, that's a big area. See, challenges when you try to do an experiment. Simulation itself is a challenge. Simulation of wind is a challenge. Simulation of building model is a challenge. Near field buildings is a challenge. Instrumentation sensitivity is a challenge. Getting correct data is a challenge. Then post processing. Everything is a challenge. It's a major experiment. It's not simple thing. You can watch some YouTube videos. You can even visit some facility. When I got the wind tunnel testing of the Lord Shiva statue done, I went to Sydney just to see what kind of good things there and was really impressed with that. I'd like to know about the wind tunnel test and how it's finding. Explained, sir. Hemanta, expect the session to be beginner friendly, basics to be. I have tried to do that, but if there are still some doubts, please go through the literature which I am sharing and then even you can ask me. No particular question, but you got to explore the facts. For wind gust design, you must understand what is wind gust design. So for that, you must go through the IS code, and there are two very good books: Wind Forces in Engineering by Peter Sachs, Petersachs, by Peter Sachs, and Wind Engineering by Simiu and Scanlon. These are two very good books which explain in detail. There is one book by Professor N.C. Nigam in Indian context also. That is also a good book. Then equivalent building model for wind tunnel testing, I have explained. You can have a rigid model, you can have a aeroelastic model, flexible model, both. Understand wind tunnel testing procedure. Explained, sir. But when it is beyond building, suppose we want to do a chimney. In case of chimney, we really make an aeroelastic model. Means it's a model which has got same dynamic characteristics as the original chimney in terms of mass distribution, in terms of stiffness distribution, in terms of natural period. In case of building, it is not required because buildings are predominantly in fundamental mode of oscillation. So a cantilever model, equivalent cantilever model works, but TV tower, chimneys, they have multiple modes of oscillation. So there we have to go. We have done a lot of chimney testings at Roorkee also. Then I'm interested in extreme event hazard assessment. I'll keep it out of course as of now, sir, for today's talk. Gust load factor. See, gust load factor is like when there is a rigid structure which does not oscillate, then it generates only the pressure. The pressure may be varying, that's all. So you only need a static pressure value. But when the structure itself is oscillating, then there is an interaction between the structure and the wind. And in that case, there is an amplification of the response. This amplification of the response because of the dynamic characteristics of the structure is called as gust effect. This gust effect is sometimes 2 times, 3 times the mean value, 4 times. So depending on the dynamic characteristics of the structure, this gust load factor is calculated in case of both along wind as well as across. Establishment of wind tunnel facility. Acha, Major Sanghvi sahab. Hi, Captain. If you are planning to have one, I'll certainly be there. I will be happy to contribute. But there are some good wind tunnel facilities coming up. You need to decide upon the level of the facility, whether you want to have it in academic only or you want to use it commercially, professionally also. Academically, you can have a small test section, half a meter by half a meter, 600 by 600, or you can have a 1 meter by 1 meter. That's all. But when you are trying to do a commercial, then you need to go for 3 by 3 meter, 4 by 4 meter kind of, and then you need everything big in that. So depending on that, a small wind tunnel facility can be established in say 5-6 crore rupees, but a bigger one, something like 30-40 crore rupees is there. Besides the building. Also, I have not explained, but let me tell you that there are two types of wind tunnel facilities primarily. One is open circuit wind and tunnel and closed circuit wind tunnel. Open circuit wind tunnel means where wind is sucked from one end and thrown outside in the atmosphere. So it doesn't come back. In closed circuit wind, the wind inside is circulated by a fan, blower fan. So same wind continues to be circulated, but it heats up. So there are heat dissipators and other things. Guna facility, IIT Kanpur facility, these are the closed circuit wind tunnels. IIT Roorkee facility or SERC Chennai facility or Thiruvananthapuram RWDI, they are open circuit wind tunnel facilities. So what are your objectives? What level of budget is there? You have to decide upon the parameters. For wind load, we are doing wind tunnel testing. Can we do the same thing for earthquake using shake table to achieve the exact value of force? How its estimation is different from it? Maybe out of course for today's talk, dear. Then I wanted to attend. I wanted to learn about this topic for so long. Feel like getting an opportunity. I'm so happy that you are looking for this, and I'm sure that this will only trigger some initial information. More we can continue to discuss. Stack wind tunnel estimation. Please explain more. I'm not able to understand what is the meaning of stack wind tunnel estimation. Waiting for the class. Need knowledge about wind tunnel structural system for tall structure as prescribed in IS 16700. Wind tunnel testing has nothing to do with that. How to work for substructure? No wind on substructure, but only the effects of the superstructure will be transferred in the analytical model. Study for tall building, Dr. Pal Singh ji. Want to know wind tunnel testing applications in oil and gas industry? Yes, several oil and gas industry structures, complicated structures, which are also slender and which have lesser permissible lateral sways and deformations, they are subjected to wind tunnel testing in many of the facilities, particularly in the coastal areas where the high winds flow. So modeling has to be done. It is very difficult to get their values right from the code only because so much closed network of the structural elements are there that it's bound to get interference from each other. I've heard about the wind tunnel testing then all building, but never got an opportunity to or witness the session and grab the technical. Okay, all the best. IS 875 part 3 for wind design. Yes, it is there. Go on reading it. Raise queries. It is under revision also. So more queries will be able to come out with a better document about the relationship between resonance, galloping, and flutter. See, when the vortex shading happens from the side, you get a resonance when the vortex shading frequency matches with the building frequency. Galloping and flutter are associated phenomena, not very common on the building side. So just for academic interest, you can read the literature. They are not very detailed explained in the code also. Wind tunnel analysis and Indian code comparison. I explained Indian code estimates conservative values. It's okay for the codal purpose. So that is why it provides you the opportunity to go as below as 70% if wind tunnel testing results are less. Dynamic CPP coefficients as per American and European codes. What is that? I need to check. इसको highlight कर दीजिए सर. Point number, dynamic CPP. 105.
105, yeah.
105. While manually calculating the wind forces for a building, generally the forces in a crosswind direction are found more than the forces in a longwind direction. However, if the calculation is provided by the wind tunnel consultant, we get reduced forces in a crosswind direction. Why is it? Actually, a crosswind force estimation as per the code is just a very, very approximate estimation, which may be plus minus 25%, even more. Because you have very limited information in the code about the crosswind forces. Your building characteristics may rarely match with that. So you get a very different value in a crosswind. A long wind is a very well detailed. There is a mean force and then there is some oscillation. It is monotonous. While a crosswind is an oscillation force, continuously changing, depends on the building frequency, depends on the resonance. In wind tunnel, you are able to get that phenomena properly recorded. That is the difference. How important wind tunnel testing is? Very, very important. Very important. All tall buildings, all complicated structures, even in the logistic parks which are being constructed in the country now, several solar panels on the rooftops, there is no treatment given in the code or books for continuously arranged industrial structures in a large complex of 200 acres or so. So whatever estimations you are doing, they may be true for the first building in the windward direction. But then all subsequent buildings have much different wind pattern. The tunneling effect between two buildings, that is not documented anywhere. So this is very, very important for low-rise buildings also, if you want to save money on that. Clauses in IS codes, like where it is must to use. It is must to use every clause. And only IS code must be used as long as the clause is available there. If not, you can refer to the international documents, codes, literatures. How the wind tunnel test generates the load combinations for the wind cases. It doesn't generate, it only gives the wind force. Rest everything you do mathematically on the software. Comparison of wind tunnel test results, I already explained. I will learn, no, applying these values obtained from wind tunnel test to relevant models, explained already. How to apply wind loads on building, how can we access? Bhavin, it seems we will have a break here.
Yeah.
I'll take up your questions now first, because
Okay.
most of the questions are now repeated.
Yeah.
If there is any specific left, we'll check it again.
Sure.
But as of now, because we'll be winding up in another 10 minutes.
Sure. Sure.
So we take up your questions.
Yeah. Sure.
I'm happy that you have so many of, you have done a lot of brainstorming,
Yeah.
homework, and have come out with these things. What are the key elements to include in terms of reference for a wind tunnel testing agency? It's a very good thing. We are preparing a document for this.
Okay.
TOR for wind tunnel testing.
Okay.
Basically, as I explained, you should be very clear about the objectives depending on the building situation, whether it is low rise, high rise, whether it is single building, whether it is multiple of the same height. So whether you need the glazing and facade study also, you need the acceleration. You people, everyone can download a very good report from RWDI about Burj Khalifa, which is available on RWDI website. At the same time, Windtech Australia, WINDTECH, Windtech Australia on their website, and they also publish a very good newsletter. If you registered, subscribe, you get that newsletter wherein they describe their wind tunnel testing projects in detail. So that will be a very good informative document for everyone. How should the TOR address unique building design features such as unconventional? This has to be very meticulously drafted, sir.
Mm.
Depending on the building shape, depending on the building usage, depending on the offsets or anything, each and every element has to be drafted. And maybe in the process, you can have a pre-bid meeting with the internal testing agency, get their inputs to finalize a common TOR
Right.
for any particular project. What is the importance of specifying dynamic response parameters in the TOR? It's not to be specified in the TOR, but it has to be provided once the internal testing is in progress. Then internal agency needs these because they deduce the story level forces. They deduce the deformation and acceleration based on these dynamic characteristics, which you as a structural consultant do based
Right.
on the wind forces obtained.
Mm.
Like that. Then we have what factors should be prioritized when defining the scope of internal testing for tall building in urban versus open terrain. See, in open terrain, it will be more dominated by a high wind velocity. So lateral deformations are more critical on facade as well as on the building foundation. Whereas in urban conditions, more of turbulence is there. So fluctuations are there. So when fluctuations are there, accelerations are there. Correct. So a crosswind response becomes critical in case of urban situation. But you need not separately define them. Whether it
Mm.
is urban or open, TOR more or less remains same. Except the cluster of building, group housing. If suppose there is a standalone structure in the open condition, then probably you may not go for the interference effect. You may not have several tall buildings or tall structures closer to that. But in urban situation, you will always have it. So
Yes.
maybe you can ask for the interference, you can ask for the pedestrian level wind studies and all those things. How do you determine the appropriate performance criteria, such as wind speed thresholds and pressure coefficients for different structural designs? It is primarily all governed by serviceability requirements depending on the use of the building. If it is a habitable building, then human perception threshold of the acceleration in motion becomes very, very important.
Mm.
Some of the performance criteria about the lateral deformation, they become on the depending on the cladding facade type. If it is a brittle cladding like glass, then there is a lesser amount permitted. So performance criteria will depend on the usage of the building, the nature of the material which has been used, the type of the glazing facade, the occupancy, and all those kind of things. Like we are designing several statues these days, tall
Mm.
statues. Now in statues, we know that there's nobody going to be there. So I can allow a little higher lateral deformation also. If I'm using a concrete skin, then a lesser value. If I'm using a bronze skin, then a higher value on the stage, like that. So depending on the usage, the performance criteria are there. Again, vulnerability. Um, Normally, in our country, we are not defining the performance criteria whether the building is situated in the city or on the in the jungle. They are going giving the same criteria everywhere, but that may be one of the parameters affecting. What challenges arise in aligning the testing scope with practical performance goals, and how can they be addressed? Exactly क्या कहना चाह रहे हैं आप?
Now, meaning, let's say, whatever results we are getting through this study and whatever goals we have, for example, we have to achieve the acceleration limit, deflection limit, etc. So, are there any challenges which could be there in a typical project?
In India, we are still not going to the super tall range. You know, we are still
Mm.
into the 300, 400-meter high.
Mm.
So the challenges are, as far as buildings are concerned, we can use dampers if there are any challenges with regard to the performance. However, in case of communication towers, yes, because communication towers cannot be allowed to oscillate much, otherwise the signal breaking will happen.
Yes.
So there you need to resort to some design changes and all those kind of things.
Right.
What criteria should be used to evaluate the credibility and expertise of a wind tunnel testing agency? As I told, their facilities, quality, what kind of instrumentation they have, how old they are, what is the team, and what is their experience and facilities in terms of the data acquisition system and instrumentation, those kind of things. Normally, anybody who will put, they will go to the professional testing once they have only done several prototype testing to evaluate themselves first. They're very, very important.
Yes. Yes.
It's a costly affair.
Yes. Very costly.
How critical are agency accreditations and what role does past project experience play in the selection process? Means,
Yeah. Meaning, of course, whether we should take this as a criteria as a past successful project, because as we understand, there are so many parameters which normal consultant may not be able to understand. Right? So maybe a past project successful, whatever number of past projects, relevant past projects have been done, right?
it can be one of the parameters,
One of the
but
parameters.
more important is the technical specifications of the wind tunnel, with right from the uh, hardware which is used to generate the wind velocity profile, to data
Mm.
acquisition, to the sensor, to the post processing. That technical specification is very, very important, and a good team of the wind engineers,
Yes. Perfect.
which is really difficult to
Mhm.
get.
Yes.
How can you ensure the selected agency's equipment and methodologies are suited to the specific requirement of a tall building project? That
Same.
once they submit, because they will, if some agency is only doing tall building or building kind of thing, they will project like that only. If somebody is doing the aerospace, they will never be, or automobile for that matter. There
Mm.
are specific automobile wind tunnel testing, like
Mm.
Honda wind tunnel.
Mm.
We have visited Honda wind tunnel also there in UK. So there what happens, since the vehicle is moving on the road, now since in the wind tunnel vehicle cannot move, so there is a moving belt below the vehicle. That belt runs, rotates, completely runs. Over that the vehicle is kept with a small gap, very small. And then the wind tunnel testing is there. So that's very specific to that. Now almost all the automobile companies, Suzuki or Honda or everybody, they have their own wind tunnels. So they will not come into the building in sector. In India, we have very less building testing facilities. But worldwide, there are many. Bridges, for bridges, there are several facilities. One of the widest wind tunnel in Japan was created specifically for Akashi Keiko Bridge, which was, that bridge actually is 4 kilometers long. And when it was to be tested, the scale was coming only to 400 meters size. Actual prototype. They created a 400-meter wide section. You can imagine how many fans they would have used. Single fan cannot work. Multiple fan wind tunnel for that width they created. Japan has amazing facilities. Amazing. So what are best practices for establishing clear communication channels with a wind tunnel testing agencies? Somebody in the organization should be assigned, should have the knowledge of the wind tunnel, wind engineering, and structure both, and should discuss with them to get to give our inputs and then to get their inputs and discuss. That's the best way of establishing the communication. How can design models and project data be effectively shared to ensure accurate representation during wind simulations? How can design models and project data be effective?
Yeah, it's a effective interface. Like already you touched upon that point
Yes,
about.
yes. How should iterative revisions based on intermediate results be managed to ensure project timelines? Generally, wind tunnel testing uh, at RWDI or Windtech Australia, they do in 6 to 8 weeks generally. So they doesn't hamper. Initial designing is always done based on the codal provisions. However, Indian wind tunnel takes a little time. They take 3 to 4 months even. So we need to plan properly, and there is no preliminary data. They do a desktop study. If you give all data and work order to the wind tunnel testing agency, they do some desktop study first and give you some primary preliminary values that can be of help. What are the most critical outputs from wind tunnel tests that a structural engineer should focus on and why? Primarily, it is the mean force in the long wind across wind direction, torsional force, and the displacement and accelerations which are used in the design. These are the important things which we should focus as a structural engineer. How can collaborate? How can collaboration between consultants and testing agencies enhance the interpretation of complex? You should continuously interact with them. You should even go to witness the test wheresoever it is happening and it is feasible. Generally, what I do, I put that clause in the TOR itself that one visit of the client's team, including a structural engineer, should be fully supported by the internal agency. आप अपने कोटेशन में ₹1,00,000 ₹2,00,000 बढ़ा लीजिए.
Yes. Perfect.
वो TOR में डाल के रखिए. That is the best way. Then go there, have a discussion, stay there for 2-3 days, see the testing, everything. That is the best way of getting into.
Yeah, that gives a real feeling, right?
Yes. तो जहां 40 लाख खर्चा हो रहा है वहां 42 लाख डजंट मेक एनी डिफरेंस.
Yes.
जहां करोड़ों का प्रोजेक्ट है, what is the best approach to use test data for aspects like occupant comfort, facade design, and aerodynamic modification?
We'll discuss
As
this.
far as comfort and the facade is concerned, that data you directly get from the wind tunnel agency. However, aerodynamic modification you need to specifically put into the scope, and then some preliminary studies should be done on the standalone model that 2, 3, 4 options. But this thing is nowadays done in the CFD more.
Yes.
So from there you go to the wind tunnel testing with the final 1 or 2 shapes. How
Yes.
can wind tunnel data be effectively used to refine structural load determination and compare? Yes. We are getting much different values. We are having lesser values also in many cases. So code also allows that. What role does test data play in assessing serviceability aspects such as building sway? We get the data from the wind tunnel testing about the lateral sway, acceleration, etc. The limits are prescribed from the international organizations.
Yes.
About the human comfort, they are also reproduced in our code, and we should stick to them. We should compare with them. What role does test data play in assessing serviceability? How can wind tunnel test results influence the performance and safety design of facade? It's very, very important, very critical. Crores of rupees are being spent on the facade. So this should be a part of the TOR that this study is required. It is there. How can wind tunnel test results influence the performance and safety design of facade? We have already discussed that. What are some common challenges faced during the wind tunnel testing? How have they been successfully? As I explained earlier, challenges are there at every stage in wind tunnel testing, and they can be addressed only by more and more experience. That's all. So when we talk to RWDI Windtech or SARC Chennai or NII Kanpur, they have everything crystal clear in their mind, and they give us 1, 2, 3, 4, 5. This way it will be done. So experience is the main thing.
Perfect.
And then could you share examples of practical lessons learned from real world projects that highlight the importance of accurate test conditions? We did Nathdwara Lord Shiva statue, which was situated on a 50-meter high hillock, and then wind tunnel testing agency collected the entire geography. We gave them the data about the structure, but since as of now there are no structures around, we showed them some area around that these can be the future developments here in India. They took Google and then they collected wind data from 3 meteorological stations around the site, airports, and then they predicted that after 250 years, what can be the wind speed, nature, and all that. So this was a very good project where the actual field conditions were, you can say, built in into the model, and then back working was done. But otherwise, every building project that we do, we have to, you can say, real data we have to provide. We are working on 200-meter high 6 towers, which are connected at the rooftop in Gurgaon. That wind tunnel testing is being done by Windtech Australia, and it's a very good discussion exercise which is going on. Otherwise, we are also getting done there's a 100 feet high sword memorial being made in Assam, Guwahati, in the memory of the Lachit Borphukan sword. It's 100 feet high. So that sword is also being tested by Windtech Australia wind tunnel testing. That's the real life project we are doing. This Maharaja Lachit Borphukan statue in Jorhat, that also we got done at RWDI. And so like this, several statues or tall building projects. But in past, I have experienced the wind tunnel testing of chimneys and some other low-rise buildings like that ONGC building in Kolkata or Dehradun Cyber Cafe building that way. So a lot of good things happening, and all these wind tunnels are quite busy, occupied.
Yeah.
Maybe we can plan a visit to Guna in Madhya Pradesh sometimes to
Yes.
see everything. That's a very centrally placed facility, and they will allow us to show
Mm.
everything. What advice would you give to ensure reliability of internal testing results and avoid potential pitfall during the process? Clarity of the scope, clarity of the dynamic characteristics of the building, clarity of the procedure, um,
Mm.
and clarity of the data acquisition system, and the whether it is high frequency force balance or high frequency pressure integration to be taken. So everything should be very discussed in detail before the actual test is done. That helps to avoid any kind of pitfall. I think good enough for today.
Yes, very, very good enough. Yeah. So with this discussion, I'm thinking that every organization have one position called field engineer. Right.
There has to be. Similar to a geotechnical consultant, similar to other specific aspect people, you should also have a wind engineering consultant or wind engineer in every structural organization, or even those developers who have got tall buildings in their portfolio. They
Mm.
should have.